In this chapter, we're going to learn how to name compounds and write their chemical formulas. That's the two most important things that we'll do. First, a little bit of a review. The smallest particle of an element is called an atom. If a substance is made up of all the same types of atoms, then that's called an element. A mixture is a sample of matter containing two or more substances, key words there, which are not chemically combined. Two types of mixtures. We have homogeneous mixtures that have a uniform composition, and heterogeneous mixtures which do not have a uniform composition. Again, keywords here, not chemically combined. As we'll see, that's different for compounds. So again, a pure substance this time, meaning you can't separate the components by physical means, containing two or more kinds of atoms, two or more kinds of different types of atoms, which are chemically combined. Be careful of molecule. This is a particle that consists of two or more atoms, which could be the same or different. We'll see some examples later that, again, are chemically combined. So let's go over again, review the composition of matter. Let's start off with four substances. Suppose we have iron, carbon dioxide, salt water, and Italian dressing. Remember that all matter can be classified as one of two things, either a pure substance or a mixture. So for pure substances can be divided up into two things, either an element or a compound. And for mixtures, we have homogeneous and heterogeneous. So iron is an element, carbon dioxide is a compound. Salt water is a homogeneous mixture, and Italian dressing is a heterogeneous mixture. This should be reviewed. All right, there are two types of compounds. They're known as molecular compounds and ionic compounds. We'll start with molecular compounds. These consist of two or more nonmetal atoms, and this does include hydrogen. Remember, just because hydrogen is to the left of the zigzag does not mean it is a metal, it is a nonmetal. We have these things called diatomic molecules. Remember, a molecule is a particle made of two or more same or different atoms that are bonded to each other. In this case, we have diatomic. Prefix di means two. So two of the same atoms bonded together. So you're going to have to memorize the elements who exist in nature as a diatomic molecule. We call these the Hofbrinkels. Hofbrinkels. So when we're talking about elemental hydrogen, it's not just, hydrogen doesn't exist as individual atoms, but rather two atoms that are covalently bonded to each other to make a diatomic molecule. Likewise, the oxygen that we breathe, oxygen gas, consists of two oxygen atoms bonded to each other. Same for fluorine, bromine, iodine, nitrogen, and chlorine. So those elements exist in nature as diatomic molecules. Let's list a couple examples of molecular compounds you may be familiar with. So here's some common ones, maybe from biology. So both of those compounds are made up of nonmetal atoms that are bonded to each other. Ionic compounds consist of ions. If you recall, an ion is a particle that has an electrical charge. We have cations and anions. And for an ionic compound, it exists as a network of ions. So if you look on page 306, we see that you have a whole bunch of cations and anions all stuck together. This makes up an ionic compound. For ionic compounds, they are usually, not always, but usually made up of a combination between a metal and a nonmetal. We'll see exceptions to this, but primarily metal or nonmetal. They're also known as salts. A couple examples of ionic compounds are these. And we're going to learn how to name these compounds. I chose 2 with chlorine. It doesn't have to be chlorine. Could be something else. Maybe that one's familiar. That's the chemical formula for baking soda, which is an ionic compound. So let's learn how to name compounds and write their chemical formulas. Of the 2, I would say formula writing is a little bit harder than naming. So here are the rules. First of all, we represent each element in a compound with its correct symbol. We're talking about symbol from the periodic table. As we saw in the examples that I just gave you, we use subscripts, and these subscripts show how many of each particular type of atom is present in the compound. Notice too, in sodium chloride, for example, NaCl, we don't use the number 1 if there's only 1 present. And in terms of ordering the elements in the formula, we write the symbol of the more metallic element first, or the less electronegative element first. Either one, it's the same thing, so that goes first. Now for ionic compounds specifically, we need to make sure we tell the difference between an ion and an atom, a neutral atom. For ions, a superscript is placed next to the symbol. So we've seen this before. We use a positive or negative superscript. So +1, +2, -1, -2, and that represents the charge of the ion. If you have a symbol just by itself, that means you have a neutral atom. For example, these are 2 very different substances. I know they differ by just 1 electron, but they are very, very, very different. So you have sodium, the neutral atom, and then you have the sodium ion. We call it Na+. Very important, letter B, ionic compounds form when positive and negative ions are attracted to each other. So remember, oppositely charged particles attract, and an ionic compound consists of the attraction between cations and anions. This is very, very, very important. When we're writing the chemical formula for an ionic compound, we need to know the charges of the ions in that compound. First of all metals, as you recall, form positively charged ions or cations. For the alkali metals, those are the metals in group 1, and along with hydrogen, all form an ion with a +1 charge. The alkaline earth metals, those are in group 2. They all form an ion with a +2 charge. Both boron and scandium families, so that is group 13 and group 3, all of those elements, except for boron itself, so below boron starting with aluminum, form a +3 ion. Nonmetals, if you recall, form negative ions or anions when in ionic compounds. Noble gases don't want to gain any electrons, so technically they don't form ions, so we'll put a charge of 0. Halogens, group 17, they want to gain 1 electron. When they do, they form a -1 ion. Oxygen's family, the nonmetals in oxygen's family, want to gain 2 electrons to form a -2 ion. Nitrogen's family, again, this is for primarily nitrogen and phosphorus, want to gain 3 electrons. They form a -3 ion. Carbon usually likes to share its electrons. It doesn't like to gain, but when it does, if it forms an anion, it will do so by gaining 4 electrons, forming an ion with a -4 charge. Again, number 3, very, very, very important. When we're writing the chemical formula for a compound, we have to keep this in mind, that a compound has no net charge, and so the algebraic sum of the charges in an ionic compound must be 0. So let's take a look at some examples. Write kind of small so we can fit a lot of them in that space. I'm going to give you the name of a compound, and then we'll come up with the correct chemical formula. All right, so here's how it starts. Take the symbol of the cation without its charge, and put it next to the symbol of the anion without its charge. So what we need to determine is the ratio of these ions in this compound. So remember, the ratio has to be such that the charges add up to 0. So sometimes I'll do a little equation to help me keep track. So the combined charges of the cations plus the combined charges of the anions must be equal to 0. So in the parentheses, let me put the charge of the cation. So if you go to the periodic table, sodium forms an ion with a +1 charge. Chloride is the ion that forms from chlorine. It has a -1 charge. And since those charges already add up to 0, we know then that the ratio of these ions in this compound is 1 to 1. Again, as I said in the notes, we don't need to write a subscript 1. So we're going to write the chemical formula of sodium chloride as NaCl. All right, let's try another one. Write the chemical formula for lithium sulfide. So again, we want to start off with the symbol of the cation, which is Li, and put it next to the symbol of the anion, which is sulfide. Sulfide is the anion that forms from sulfur. Next, we want to determine the charges of these ions. Lithium has a charge of +1. Sulfide has a charge of -2. Do those charges add up to 0? Not in a 1-to-1 ratio. So what is the ratio that is needed for those charges to add up to 0? So it looks like we need 2 of the +1 ions for every 1 of the -2 ions. So how do we show that in the chemical formula? We need 2 +1 ions for every 1 -2 ion. We're going to take that 2 that's outside the parentheses and use that as a subscript in our formula. So the chemical formula for lithium sulfide is Li2S. Go ahead and try this one. Write the chemical formula for calcium bromide. Pause the video while you work on this. Calcium has a charge of +2. Bromide, which is the anion that forms from bromine, has a charge of -1. Now I know what some of you might be thinking. Isn't bromine diatomic? Isn't the formula for bromine Br2? So don't we have to put a 2 after bromine? Not necessarily. It may end up working out that way in this particular example, but we're talking about when bromine or chlorine or oxygen or hydrogen are by themselves that we write the 2. When we're writing the formula of an ionic compound, we need to use subscripts that indicate the ratio of the ions. So this is bromide in this compound, not bromine. Actually works out that we do need 2 bromides for every 1 calcium. And so just by coincidence, we have Br2, but it's CaBr2. If it was just bromine by itself, certainly be Br2. Look at the example, sodium chloride. It's not NaCl2. Only when chlorine's by itself is it Cl2. In a compound, it may or may not have A2. Let's try one more. Go ahead and write the chemical formula for aluminum oxide. Oxide is the anion that forms from oxygen. So go ahead and follow the process that I've used and write this formula. So here we see that aluminum has a +3 charge. Oxide has a charge of -2. So do those charges add up to 0? If not, we need to make them add up to 0. So for this one, I would use the least common multiple. So what is the least common multiple of 3 and 2? That would be 6. So make the +3 +6, we need 2 of those. Make the -2 -6, we need 3 of those. So the chemical formula for aluminum oxide is Al2O3. So for all the examples we've done so far, we've had compounds that have monatomic ions in them. Na+, Ca+2, Al+3, Cl-, O-2, S-2. Those are all monatomic ions. The prefix mono means one. We do have these ions that are made up of many atoms. We call them polyatomic ions. So these are a group of atoms that act as a single ion. In naming or formula writing, as always, the positive ion is listed first, whether it's monatomic or polyatomic. In naming, as we'll see later on, do not replace the last syllable with the "ide" suffix if the negative ion is a polyatomic ion. So notice in the names I gave you on the previous examples, they all ended in the suffix "ide." All monatomic anions end in "ide," like chloride, fluoride, bromide, iodide, oxide, sulfide, selenide, nitride, and phosphide. But if the anion is polyatomic, it likely is not going to end in ide. When writing a formula, if more than one polyatomic ion is needed, you're going to place the polyatomic ion in parentheses, and then the subscript will go outside of the parentheses. Now, if you look in your book on page 169, there's a pretty small table. In the back of your book is a larger table of the polyatomic ions. There's some that you need to memorize. Let's start with that. So I'm going to list these by charge. So I'm going to start with the -1 ions that you need to memorize, the -2, the -3, and then the +1. So here are the polyatomic ions you need to memorize. I already gave you flashcards of these, but I figured to put them in the notes as well. Make sure to not only know the formulas, but know their names as well. So I've just listed formulas here. Of course, your flashcards have both the name and the formula. So a couple polyatomic ions to be careful of. If you look in the list, most of the polyatomic ions end in ate or ite. There are some exceptions. Here's another one you need to know. This is cyanide, ends in ide, even though it's not monatomic. Likewise, hydroxide is polyatomic, but it ends in ide, just like a monatomic ion. Though there are more than one polyatomic cation, this is the only one you need to know. This is called ammonium. And then one more that has a little different name. This is called dichromate. So we'll need to know that one later. So definitely the ones under number 6 plus cyanide, memorize those as soon as possible. All right, let's do some examples of compounds that contain polyatomic ions in them. So again, I'm going to give you a name and we'll write the chemical formula. So let's write the chemical formula for potassium nitrate. Now we want to start off the same as what we did before. This time I'm going to use a little different word. So you're going to take the symbol or formula, if it's polyatomic, of the cation and put it next to the formula of the anion without the charges. We never include charges when we're writing formulas of compounds. So ions by themselves, we indicate the charge as a superscript. When we put them together to make the formula of a compound, no superscripts. So potassium, symbol is K. Nitrate, be careful with nitride, which is monatomic, versus nitrate, which is polyatomic. So when we see that ate or ite suffix, that is our clue that this ion is polyatomic. So we want to do like we did before. Since this is an ionic compound, we want to determine the charges of each of the ions. Potassium has a charge of +1. Nitrate has a charge of -1. Do those charges add up to 0? Yes, they do. So what then is the ratio of the potassium ions to nitrate ions in this compound? That would be 1 to 1. So the chemical formula for potassium nitrate is KNO3. Let's try another. Let's write the chemical formula for sodium sulfate. Sodium is a monatomic ion, symbol is Na. We see that ate suffix, sulfate, which tells us the anion is polyatomic. Be careful with sulfate versus sulfite. Sulfate, SO4. Charges? Do those charges add up to 0? If not, make them add up to 0. So what do we need to make them add up to 0? We need 2 of the +1 ions for every 1 of the -2 ions. So let's use that as a subscript. So the chemical formula for sodium sulfate is Na2SO4. Let's try another. So again, start out the same way. Calcium is Ca. Hydroxide, be careful, you're just going to have to memorize that. Hydroxide is not monatomic. It's not H by itself. H by itself is called hydride. This is hydroxide. Charge of calcium ion? From the periodic table, we can figure that out. Charge of hydroxide. Need to memorize that. Do the charges add up to 0? If not, make them. So it looks like we need 2 of the -1 ions for every 1 of the +2 ions. So we need 2 hydroxides for every 1 calcium. So let's do that. What does that mean? This is not correct. If we put the 2 like that, that means 2 hydrogens. We don't want 2 hydrogens, we want 2 hydroxides. So how are we going to show 2 hydroxides? Put the whole polyatomic ion in parentheses, and then the subscript outside of the parentheses. Let's try one more. I'll let you try this one on your own. Go ahead and write the chemical formula for ammonium sulfite. Go ahead and pause the video to do this. In this example, both the cation and anion are polyatomic. Ammonium has a charge of +1. Sulfite has a charge of -2. So that means we need 2 ammoniums for every 1 sulfite. All right, if that wasn't challenging enough, let's take it a step further. Predicting charge for positive ions with more than 1 charge. So some metals can form more than 1 ion. And so we have to show in the name which ion it is. Here's how it works. When a name is written for a compound that contains a positive ion with more than 1 possible charge, Roman numerals and parentheses are placed immediately after the name of the positive ion to signify the size of the charge. I guess it's really important because here it is again. Roman numerals represents the size of the charge of the cation. Not, I repeat, not the quantity of the atoms. Be careful. Here they are. Iron can form more than 1 ion, +2 or +3, depending on the compound. Lead can form 2 ions, +2 and +4. Tin can also form +2 and +4. And copper can form +1 or +2. So for all of these metals, when we name their compounds, we're going to use what's called the stock system, which means that we're going to use Roman numerals in the name. Number 4, there are a couple other metals to be careful of. We can't determine their charge from the periodic table, so you just need to memorize them. Zinc has a charge of +2. Silver has a charge of +1. Again, all of these are on the flashcards I gave you, so should already have these memorized. All right, here's a couple examples. Let's write the formula for tin 2 bromide. Start off with the symbols for our anion, our cation and anion. Tin is SN. Bromide forms from bromine, that's Br. A little easier than what we did before, because this time we don't have to look at the periodic table. What is the charge of tin in this compound? Well, it tells us right here, it has a charge of +2. Bromide, we know, has a charge of -1. Let's make those charges add up to 0. So for tin 2 bromide, we get SnBr2. How about copper 2 oxide? What is the charge of copper in this compound? It is +2. How do you know? The name tells us. Since those charges are the same, the ratio of those ions will be 1 to 1. The formula for copper 2 oxide is CuO. All right, let's back up in the notes. Let's go to our previous examples we did, and let's flip it around. Let's take a chemical formula and turn that into a name. Naming ionic compounds is really easy. Take the name of the cation followed by the name of the anion. What is the name of Mg? Now, we don't care about the 2 there in Cl2. All we need is the name of the anion. The anion in this compound is Cl-. There's just a 2 there because the charge of Mg is +2, and those charges need to balance out. So Cl- is called chloride. So MgCl2 is called magnesium chloride. Let's try another. let's name this compound. The cation in this compound is zinc. The anion is not oxygen. Remember, all the names of the monatomic anions end in "ide." So we're going to take off the last one or two syllables, depending on the name, and add the "ide." So this, for chlorine, take off the "ine" and add "ide." For oxygen, it's not take off the last syllable and call it oxygenide. Actually take off a couple syllables. Make this oxide. Let me give you a couple to do on your own. Go ahead and pause the video and name these two compounds. So the ion formed from selenium is called selenide, so we get lithium selenide. And N-3, that ion is called nitride. So our last example there is sodium nitride. Let's try some with polyatomic ions in them. So again, we're going to turn it around. I'll give you a formula, you write a name. All right, just to remind you, naming ionic compounds is very easy. Name the cation first, then the anion second. In the formula, the cation is listed first, anion second. So we need to know where they are. So I'm going to draw a line between the cation and anion's formulas, just so you can see where they are. Name of the cation. Anion is polyatomic, so the anion's name is, so this compound is called lithium nitrate. Let's take a look at the next one. Name of the cation is magnesium. Name of the anion, it's a polyatomic ion, OH minus, is called hydroxide. Go ahead and pause the video and try that third one listed there. This time the cation is polyatomic and the anion is monatomic. NH4 plus is called ammonium. Cl minus is called chloride. So the name of this compound is ammonium chloride. Let's take a look at some examples where we have this situation, where the metal can form more than one ion. All right, so we see a couple compounds that contain copper and chlorine. Again, copper can form more than one ion, and so we need to show which ion it is in a particular compound. So let's start with this. Since we know copper is going to does form more than one ion, we know we're going to use a Roman numeral in the name. Let's start with that. So the name of this compound is going to be copper something chloride. And what goes in parentheses is the Roman numeral that tells us the charge of copper in this compound. Well, what is the charge of copper in this compound? Well, here's what we're going to do. We're going to use what we know to find what we don't know. We know the charge of the anion. We're going to use that to find the charge of the cation. So we know the anion has a charge of -1. We have a 1-to-1 ratio in this formula. So what goes in parentheses? What makes that equation add up to 0? +1. So that means the charge of copper in this compound is +1. How do we show that in the name? We're going to use a Roman numeral. So we write copper Roman numeral 1 chloride. We name it as copper 1 chloride. So Cu plus 1 has a name called copper 1. Let's try the same thing with the next one. Use what you know to find what you don't know. So notice this time we have 2 chloride ions according to the formula. So I put 2 -1 ions. We have 1 copper ion in that compound. So what goes in parentheses in our equation? So the charge of copper in this compound is +2. How do we show that in the name? So the name of this compound is copper 2 chloride. Let me give you a couple more to try. Go ahead and pause the video and name those two compounds. Both tin and lead can form more than one ion, so the names of these compounds will both include a Roman numeral. Pause the video. Did you put tin 2 oxide for the first one there? Remember, oxide has a charge of -2. There's 2 of them according to the formula, only one tin. So that means its charge must be +4. This is tin 4 oxide. Next one there, I mixed in Roman numerals with polyatomic ions. We have lead 2 nitrate. One more. Go ahead and pause and give this one a try. Did you get copper 1 sulfide or copper 2 sulfide? Sulfide has a charge of -2. There's just one of them in the formula. This time we have 2 coppers. So what goes in parentheses? That'll be the charge of copper, so it's got to be a +1. Therefore, copper 1 sulfide. All right, we'll do a lot more practice in class if you need. Make sure to review this, memorize those polyatomic ions, memorize those metals that can form more than one ion as well. Thanks.